Welcome. My name is Lynn McManus, and I'll be the moderator for this Engineers Without Borders webinar, How to Complete the 525 Pre-Implementation Report. This presentation is one of the core programs in the expanding series of online, on-demand continuing education programs created by Engineers Without Borders USA and presented by Contract Solutions Group. Before I turn the program over to our presenter, I'd like to make a couple of announcements regarding the program. As our program begins, you'll notice that the program itself will fill the majority of your computer screen. On the lower left of your screen, you'll see a pause play button. If for any reason you need to pause the presentation, click once on the pause button. To restart the program, simply click on the play arrow that will appear in the same place. If you should need technical assistance, please click on the email link for Client Services at Contract Solutions Group, located on our website pages. Or you may call us for assistance from 7 a.m. Pacific Time until 4:30 p.m. Pacific Time, Monday through Fridays. If you're disconnected from the webinar due to local internet issues, simply log back in through the Engineers Without Borders website and restart the program. After the program, you'll be taken directly to the attendance reporting page. It is very important that you complete this short form and submit it immediately upon completion of the program to receive full credit for your participation in the program. If this step is bypassed, neither you nor your chapter will receive credit. Now it's my pleasure to introduce our presenter for the program, Peter Waugh. Peter earned his BS and MS in Civil Engineering at the University of Colorado in Boulder, and has a total of 25 years' experience working in water resources, structural engineering, and roadway engineering. He's been a project manager at the EWB-USA National Office since January 2008. Peter served in the Republic of Seychelles as a Peace Corps volunteer and has worked on EWB-USA projects in Mexico and Guatemala. He's a licensed professional engineer in the state of Colorado. Peter, I'll turn the program over to you.
Thank you very much for that introduction. And thank you to the chapters who have tuned into this and elected to look at our webinar about how to complete the 525 pre-implementation report. The intent of this webinar is to assist chapters in preparing the document, hopefully help them make it a better document, and hopefully take some of the stress out of preparing the document. Here at EWB-USA, we like to start all our webinars kind of in the same way, and that's by showing our vision and mission. And the reason we do this is not really to go over the exact wording of the vision and mission again, but just to remind everybody that really this is what holds us all together, all 12,000 of us, volunteers and employees in all the chapters around the United States. This is what keeps us all going in the same direction. And so we like to just to remind everybody of that as we start our webinars. What we're going to cover today, firstly, we're going to go over some background information for the EWB-USA program quality and project process. Secondly, we're going to tell you just about some general expectations for completing this report. It's impossible to go over all the details for preparing the 525 pre-implementation report because there's so many different types of projects, but we're going to go over the general expectations that we have for completing the document. And what we're not going to cover is detailed guidance for completing the document. We're not going to lead you through it, step by step, because there's just so many variations on how to do this. So first of all, let's go over some of the background for our program quality and project process. So EWB-USA has over 12,000 volunteers working in 250 chapters, working on 400 programs in over 45 countries. And the national office has 4 technical staff to oversee these projects. Needless to say, we need some fairly rigorous methodology to keep everybody going in the same direction with so many volunteers and programs and projects. So in order to manage this, we have this rigorous project quality program. It's an integral part of this program is our project process. And the project process is based upon standard engineering methodology of identifying a problem, assessing that problem, doing a design, implementing, and then monitoring after you've done implementation. And I think a lot of student chapters get the idea that the project process maybe is just a bunch of hoops to jump through in order to be able to travel, but that's really not the case. It's based upon standard engineering methodology. It's also what you're going to be doing as engineers your entire professional lives, because this is what engineering is. So here we have the whole project process from the first pre-assessment that you do down through program closeout. And any one individual working at a chapter may have to do 2 or 3 or maybe at the most maybe 4 of these reports during your time in the chapter. But to get all the way through program closeout is likely over 5 years, and so you're not going to have to go through all of it. But what we're talking about today specifically is the 525 pre-implementation report. And so let me just go, but before telling you what we expect you to put in the document, let me just tell you how we at the National Office go about reviewing the document. The first thing I have to say is submit your document according to the schedule on the EWB-USA website. I can't stress strongly enough how important it is to make that deadline, because if we run through things on a batch process, kind of a monthly process. So if you miss our deadline by 2 days, you may think, gosh, I've only missed it by 2 days. But I, as the project manager, won't see it for a month till the following month. So you think you're 2 days late. In my view, you're 30 days late. And since we get so many documents to review, we really can't make any exceptions for folks who turn stuff in late. So all I can say is make sure you've submitted it on time. So once you've submitted it, the first thing we'll do is the project manager will pre-screen the document. And by that, that's kind of a 4-step process. Number 1, we'll make sure there's a standalone health and safety plan attached to it. Number 2, we try to make sure that the mentor who is listed on the document has been actively involved in the preparation of the document and has been actively involved the entire time it's been put together. We don't want some mentor that was just, put on at the very end because you needed somebody's name in the mentor slot. We're going to check for the calculations, and that means we check that they're complete, they're indexed, and they look like professional level calculations, not just a bunch of calculations that are splashed up there willy-nilly. And then lastly, and maybe most importantly, we look to make sure that there are complete drawings for the project. If any of those is not true, then your project will fail the pre-screening. What this means is, well, first of all, we'll email you and let you know what the deficiencies are and why you didn't pass the pre-screening. You'll be asked to correct the deficiencies and resubmit the document. What that means, though, is that you're going to be postponed likely you'll have to resubmit the following month, or maybe even the month afterwards. That will likely mean that you're going to have to postpone travel. And so all I can say is, those 4 items, the health and safety plan, mentor actively involved, calculations, and drawings, make sure you have those bases covered before you turn in your document. And so if your project does pass the pre-screening, the first thing that will happen is the project manager will do a complete review of the document. And then after that, you'll have a phone call with your project manager to discuss the project. Even at that point, the decision that the project manager is making really is, are you ready to present to the technical advisory committee or not? So the project has to be well enough formed, and the engineering has to be sufficient in order to present it to the entire technical advisory committee. Because we don't want you to present to the 10 people on the TAC if you're really not ready to go. It's not fair to them. It's also not fair to you. And the few times that that's happened, the chapter regrets it. They had wished they had been asked to postpone for a month. So after you're approved by the project manager, then you will present to the technical advisory committee. The technical advisory committee decision will be either you're approved, you're on hold, or you're declined. And so, you may be asking yourself, what exactly can we do in order to make sure that we're approved by the technical advisory committee? If it was easy enough that we could just give you kind of like a boilerplate or some menu, you just do these exact things and you will get approved, we do it. But there's so many different kinds of projects, there's so many different kinds of communities and chapters that there's not one prescriptive way of just making sure you do everything right. Essentially, what we try to make sure, and what the TAC tries to make sure, is that your chapter has met the 2 fundamental canons of the Code of Ethics of the American Society of Civil Engineers. Those are, number 1, engineers shall hold paramount the safety, health, and welfare of the public, and shall strive to comply with the principles of sustainable development in the performance of their professional duties. I mean, really what that means is the TAC is going to try to decide, have you done sufficient engineering that the safety, health, and welfare of your the community that you're partnering with, is that going to be protected? If they're in doubt about that, you will not get approved. And so that's why it's so important to show that you've done this work. And then secondly, the second fundamental canon, engineers shall perform services only in their areas of competence. Really what that means is we are looking, the project managers are looking, and also the technical advisory committee is looking to make sure that your mentor is appropriate for the type of work that you plan to do. So that was how the document gets reviewed. Now let's go into the document itself. So there's 2 parts to the document. Part 1, administrative information, and then part 2 is the technical information. So let's go over part 1, administrative information, first. A couple tips for completing it. Really, the administrative information is really kind of slam dunk. This shouldn't take you more than a couple, 3 hours to put together. It's all just a fill-in-the-blank exercise where we ask for names and phone numbers and dates of when you're going to travel and the latitude and longitude of your community and things like that. It's all data that's right out there. You should have at your fingertips. Tips for completing it, really there's only 2 tips. Number 1, use the exact format that we ask for, because that's what our data entry clerk then uses to put into the database. And number 2, complete every single section. And some red flags for part 1. If you have a travel team larger than 8 people, that is a red flag. It may be that your project needs more than 8 on the travel team. If that's the case, that's fine. Just provide a compelling explanation why that's the case. In almost every case, the project would benefit from a team of 8 or smaller, and the needs of the project and the community always come first. That's what sets the travel team size, not the number of students at the university who want to travel to the site. Secondly, if you have an incomplete travel team, if you just leave it blank or something like that, again, that's a red flag. We understand that sometimes you don't have the exact team members set yet. That's okay, but fill it out as best as you can. This is in tabular form. So if you don't know the names of the students yet, just put student 1, student 2, student 3, so that we know how many there will be. You do have to have the 2 health and safety officers set at that point, unless you have a whole bunch of them on your in your chapter and you can pick from a bunch. In that case, you can just put health and safety officer 1 and health and safety officer 2. But you do need to have the name of the mentor that will be traveling, and so make sure to have that name down there. If there's no mentor listed or no mentor resume, as we talked about before, that's a big red flag. If it's an inappropriate mentor, by that we mean not enough experience or experience in another facet of engineering other than the work that they will be doing, it's a big red flag. No health and safety officers is an issue. If you have no travel dates at all listed, again, that's an issue. If you don't know the exact dates yet, just give us all the information you can. It may be that you say the team will be traveling for 10 days sometime between December 15th and October 21st. That's fine. We can go ahead and do that. If you have a very short or a very long trip, again, that's a red flag. Sometimes they may be warranted. That's fine. Just make sure then in the next part of your document, in the technical portion, to explain why you have such a short or long trip. A late submittal based on the travel dates, what that means is you've met the deadline on our website. So let's say you made the October 17th deadline, but you wanted it for an early December implementation, when really the October 17th deadline is for a January implementation. That's going to be a significant issue. And then if there's no record of any kind of a post-assessment document from you, you did one trip, an assessment trip, you never told us anything about what happened on that trip, and then you went right to implementation, that's also going to be a red flag for us. And so now let's get into the guts of the document, and this is the technical information, part 2. And for this part of the document, we have an example or a proposed outline that you can use. A lot of chapters find it useful to use that outline, but you don't have to. If you have another outline, another way of presenting your report, your project that better shows, the details of the project, by all means use it. So you should use Part 2 to, as clearly and as concisely as possible, describe your proposed project and your proposed trip. And so what are the parts that go into this Part 2 then? What do you describe? Well, first of all, we want some introduction and background. And again, you should put into this document what's appropriate for your project and for your program. So, the first thing we have listed here is describe the physical aspects of the community, like the location, geography, size, water resources, etc. But you want to focus on those portions of the physical aspects of the community that are really important for your project. So let's say that you're doing a bridge project. What would be important is the waterway that you're crossing, a description of that, maybe the size of it, and the size of the watershed above it, things like that. And then when you talk about existing infrastructure, the water system in the neighboring community isn't of that much importance. But what would be important for this, for a bridge project, would be, of course, what are the approach roadways like? What is the current traffic? How much traffic does it get? Things like that. So remember to make this specific to your project. Don't just click off, the few things we have listed here: location, Bing; geography, Bing. Just make sure that you hit those items that are important for your project, and to describe to the Technical Advisory Committee what your community is like. Secondly, describe the social aspects of the community. And here again, you want to focus on those aspects that are important for your project. So let's say you're doing a water project. Well, if there is already a water committee that has been organized in the community, and they meet regularly, and they already manage, let's say, a spring or something like that, well, that's really important to know. We want to know about that. So go ahead and describe that. If, on the other hand, there's some other, if there's a government structure that's not really important to exactly what you're doing, you may want to give one sentence to it, that there's a municipal government and these are their roles and responsibilities, but for the water system, they have no authority. That's fine. That's all we need to know. You don't have to go into a lot of detail about it. Going on a little further, describe the previous trips that you've taken to the site. Really, again, just really briefly, this is the date, this is what we did. I think if you should be good enough writers by this time that you could probably describe succinctly in about 3 sentences for each of the previous trips to the site. This is what we did, and this is how it fits into the greater whole. You may not even need 3 sentences. You may just need 1 for each trip. And then, again, what is the exact problem that you're trying to solve? During this specific trip and with the project in general. So if you're, for example, trying to, if this is a water quality project, you're trying to do water treatment for the community, just give the background that there are, let's just say, 150 households in this community. They currently draw their water from an open water source that is polluted with fecal coliforms and whatever else is in the water, and give a short synopsis of that. And then if there's any health data, let us know about that. And then that goes to the heart of the issue of what the exact problem that you're trying to solve is. If on the other hand you're doing a bridge project, all that water quality information, et cetera, we don't need to know that. We don't need to know that until you get to the water quality part of this program, if you ever get there. Really briefly summarize the alternatives analysis that you went through as a chapter, the thought process you went through to come up with the exact design that you've come up with. This may have been done previously. It may be that you did an alternatives analysis and you submitted that to the EWB-USA office for our review. We reviewed it and we've gone back and forth. If that's the case, great. Just give us a real short synopsis of it. If you didn't do that, you might want to go into a little more detail. Just why you ended up with the design that you have. And then summarize the data that you've gathered for the project and the analyses that have been carried out. So, what this goes back to is the technical advisory committee, and for that sake, the project managers also. Really, we don't know anything about the project unless you tell it to us. You may have been, you did a 3-week assessment, earlier, and you've done documents like the post-assessment document. You spend, week after week after week working on the design. You know all about it. We, on the other hand, know absolutely nothing about it. So unless you summarize the data that you've gathered, you may know in the back of your head, oh yeah, we're doing things, we're sizing the bridge because for this waterway opening, yeah, because we know this is what the flow of water through there is. Unless you lead the project managers in the TAC through that thinking process, we don't know how you came up with that. So you have to be real careful to summarize this data and let us know everything that your project is based on. So next in line is the facility description. And strangely enough, this is one place that a lot of chapters seem to kind of, trip and fall down. You have to, in some manner, either using text or a drawing or a sketch of some kind, you have to provide a concise, complete description of the planned implementation. You're going to go into a lot more detail later on with your drawings and calculations and all this, but you should have a couple paragraphs that really describe what you plan to implement, or it may just be one little sketch. I mean, one way to picture this is that you're having dinner with some friends, and they're not engineering students, and so they're asking you, what are you going to Honduras to implement? And so you pull out the napkin and a pen, and you just sketch out. This spring box is already existing. You draw that in. You draw a line. We're building this pipeline. It's a 1.5-inch diameter PVC pipeline. And then you draw another little circle and say, this is a plastic storage tank that we're implementing, and it's 5,000 gallons, and then you draw another line and a little tap stand at the end of it and say, so we're then installing a little more pipe, and then there's going to be a tap stand or like a spigot at the end of it. That tells your friends at dinner what you're doing. It also tells the TAC in the barest forms, this is what we're asking for permission to implement. This is so they don't have to start going through all the details without really knowing at the most basic level, this is what the chapter is asking permission to implement. Because if the TAC doesn't know what you're asking permission to implement, that clearly they can't approve it. So, I put this down here, if this last point, if the reader can't tell what you plan to implement after studying this section for 5 minutes, then this section is deficient. And I had originally put 2 minutes in here, but I lengthened it to 5 to give everybody a little extra time. But basically, you should be able to give this paragraph to anybody at your university, and they should be able to know what you're implementing just by reading that. So let's go over briefly the calculations, what is expected from you. The general expectations are, number one, you include calculations for every component of the design. All the assumptions are made clear in these calculations. We don't want to be, searching through, gosh, we know that, they've designed this foundation, but nowhere can we find what the allowable bearing capacity of the soil is. You have to make all the assumptions clear and make them clear up front. Include a summary of the calculations in the body of the report and complete calculations in the appendix. And so really, we don't want page after page of calculations in the body of the report. That gets kind of difficult to read through. But if they're all in an appendix, and then in the body of the report, you can just go through and say, we estimated the supply from this source to be whatever it is, 20 liters per second, and we estimated the demand to be however many liters per day, let's say 5,000 liters per day, and then in the appendix of the report, you can then state the 5,000, how you got to that 5,000 liters per day. And make the calculations readable, annotate them so we know where, we being project managers and the technical advisory committee, we know where we're going when we're reading these. If you just submit page after page of computer output, it may mean something to you, and if we study it long enough, we'll probably figure it out, but, we don't really have time to do that. So tell us everything, show us on the computer output, this is the input, this is where the input came from, this is the output, this is the units, this is what it means. Make all that clear to us. And continuing with the calculations, let's just go into some detail about what you'd want for a water supply project. Number one, we need to know what your estimated supply is, the estimated demand, and you need to provide a comparison of those two. Without knowing those two things, there's really no place to start any kind of a water resources, water supply project. And so if you don't have a supply-demand calculation, you will not be approved to present to the TAC, I can guarantee you, because there's really anything else you've done, if you don't have this, is basically useless. We want to see all your calculations for sizing of the facility, the storage, how did you come up with the 5,000 gallons, say, storage. You're building that kind of that size of a storage tank. Well, how did you come up with that 5,000 gallons? Show us the calculations that show us how you get there. The piping, how did you come up with the size and what the type of piping, the pressure rating, and all the appurtenances that you may use. How did you size those? We will want to see pipe operating pressure and a hydraulic grade line and all the head losses. And this is usually just done on a plan and profile. You can show the hydraulic grade line on a profile, and that works really quite well. Any site civil or structural design that is needed, we want to see those calculations, and then if there's any water treatment process design, we want to see those. So this is just in the most basic sense, this is what we will be expecting at a minimum for your water supply project. You may have a specific problem in your design that you need something else that's not listed here. Well, you have to supply that. You can't just say, oh, well, you didn't have it listed in the calculations we had to show. This is really just a bare minimum. You may need, and you probably will need additional ones. I just don't know what they are because I don't know what your exact project is. And so now let's look for a little bit at what kind of structural calculations you'd need. Number one, the design loads. I can't stress this strongly enough. You have to say at the start of all the calculations, these are your loads. And you have to have that backed up with some kind of documentation that it's appropriate for this area. Secondly, the material strength. We need to know what you're assuming for the material properties for everything in your that you're using in your project. For the soils, you have to let us know, whatever's appropriate for the structure you're doing. It may be that the only thing that matters is the bearing capacity. Fine, tell us that. It may be that you need to know the passive and active earth pressures for a retaining wall. If that's the case, then tell us those too. But tell us up front, these are the soil characteristics. Then we need calculations for every component of the structure and the structure as a whole. If there's any little bit of the structure that has not been designed and there's not a calculation for it, be prepared that it will be considered deficient because you were expecting a calculation for it. We'll expect that your design, your calculations are compatible with local construction practice and local experience. And then always remember to include formwork calculations for concrete work if it's appropriate. So now let's go on to the drawings, and we'll start with general expectations. These should be a complete depiction of the facility. It's not some conceptual level sketch. And anything you intend to construct has to be described as in a drawing. And the one thing I would say is, we have a lot of example drawings on the EWB-USA website. We have some ones that I would consider great drawings, including a bridge drawing on there. And then we have some that I would consider real good, including some water system drawings and a structure. And those, of course, are not appropriate for your specific project, but they let you know the level of effort that is kind of required in order to get approval from the Technical Advisory Committee. So let's go on now to some specific instances of what would be required for drawings, and for structures, and let's start with buildings and tanks. Number one, cover sheet, including a location map and a site plan, foundation and floor plan, roof plan, building sections, building elevations, and wall sections. And if students that are looking at this webinar, you may think to yourself, God, I have no idea what those are, to which we can only say, we understand that because when we were students, we had no idea what they were either. But your mentor does, or your mentor should, and they will lead you through the process of putting these drawings together. We don't expect you to know how to do this, but we do expect you to be able to do it with adequate guidance from your mentor. An important thing to remember about drawings is that a lot of times your professor may not be the best person to tell you about, what goes in a drawing, because they're just not that experienced with it. And so you're better off with a practicing structural engineer when it comes to drawings. And so let's just continue with, structural drawings, buildings and tanks. You'll want structural member drawings for concrete members, connection details if there's any wood or steel, reinforcing bar bending diagrams, what we call here in the States shop drawings. If you have a building and it's gonna have electricity in it, we need to see the electrical wiring diagram. If it's going to be plumbed, we also need to see the plumbing diagram. And so again, that is just kind of the barest outline of what we would expect for drawings for buildings and tanks. So let's do structures now. Bridges, again, cover sheet, including a location map and site plan. We want to know how the approach roadways fit into, the whole thing, how they connect to the bridge. We'd want to see abutment, plan view and sections. If you have piers, the plan view and sections, and then the bridge superstructure, plan view and sections. And going on with the bridges, any small details like connections, guardrails, things like that, we'd want to see. And this next one is quite important. A lot of times for bridges, the most difficult design work that you do is actually the false work or the form work for the construction phase. So you have to build wooden formwork in order to hold up the concrete while it's wet, before it cures and hardens and forms a structural section. So the construction phase may be the more difficult portion of the design that you do. And then lastly, drawings, shop drawings for reinforcing bar placement. This really is just to help you kind of transition from the, the drawings of the bridge itself to building it. The shop drawings show you exactly how long each reinforcing bar is and where the bends are, and that will help you when you're at the site. And so now let's go on to water systems. We'd want to see again a cover sheet, any structural drawings for tanks, some kind of topographic map or sketch with the components on the system overlaid on it, and then any other items that are really important for for your specific situation. It may be land ownership's real important. If that's the case, let us know. It may be land use is, it's different. If you're going through a busy town, it's real different than going through open country. So you need, if you're going through open country, you may not need to give us as much information about the land use. If you're going through town and there's other buried utilities, you're going to have to give us a lot of information on the drawings. You need to show the piping size, material, and then a trench section, and you need to show this in plan and profile. And then any appurtenances that you need, and there's a lot of these, valves, thrust blocks, pressure relief valves, all this stuff, you've got to show in some detail, and you likely will get a lot of questions about this from the Technical Advisory Committee, because a lot of times one little thing, the loss, or you didn't put in, say, one pressure relief valve, or you left out one clean-out valve, and that's what can make the entire system inoperable. And you have, 3 kilometers of pipe that are great, but this one valve is ill-considered and has been placed improperly, and that's what makes the whole thing not work. Pumps and pumping stations will need some information about that. And it's enough information for the Technical Advisory Committee to really make sure that the pump will work, it'll work on the long term, and it is operable and maintainable by the community. Any electrical wiring diagrams, for the pump and pumping station. Controls can be important if you have a pump and a tank that are remote from each other. It can be, those can be real important. Sometimes there's no controls at all, in which case clearly you don't need anything there. If there's any water treatment, we need to know what that looks like. So that was, in general, what you need for drawings. And again, if you have any questions about that, we recommend that you go to your mentor, work closely with your mentor so they can assist you through the process. So construction, this is the point in the 525 document where you show the Technical Advisory Committee. So you've convinced them with the drawings and calculations, you've convinced them that you know how this thing should be designed. Now you're in the construction part of the document. Now you have to convince them you know how to build it. And it could be that that really the chapter isn't doing much at all in the way of building because you've hired a contractor or the community is doing the work. That's fine. The first thing you want to show in your construction portion of the document is let us know what is the role of the chapter. Are you the construction manager? Are you construction oversight? Are you essentially the client's representative? Are you the labor? Are you building it? You have to let us know what role you have. And then who will do the actual construction. And then there should be detailed planning for the construction process. And the planning should show us that you have a good knowledge of the tasks that need to be done, how long those tasks take, which tasks go before other ones, etc. There should be a list of materials, labor, equipment, etc. And then this one is real important. Have you constructed a prototype? What the TAC is guarding against is the occasional chapter that wants to go to the site and, for example, show the community how to build a ferrocement tank, but they've never done it themselves. You are never going to get approval from the TAC to actually build something if you don't have experienced personnel on your team in doing that. It could be that you're depending on construction expertise in country to do the work, and you have done a thorough job vetting a construction company that will do the work. If that's the case, that's fine. Then we don't need to know that you know how to do it. We just need to know that you've investigated this construction company that's in country and that they know how to do it. That's fine with us. And then, have you had any special training at your university? And then, who has built a similar facility? It could be that, it can be as simple as just, you've learned at your university, you've practiced gluing pipes together. That's fine. It may be as simple as that, or it may be, gosh, our mentor does this for a living. He's a construction engineer, knows exactly how to do this. That's great. Then he can take or she can take the lead role in that and train the rest of you. You just have to let us know who knows how to do all this stuff. Operation and maintenance. So you've convinced the TAC that the design is good. You've also convinced them that you know how to construct it. Now you have to convince the TAC that this project is going to be operated and maintained in the long term by the community, and that the community has all the resources it needs in order to do this operation and maintenance. So the first thing you're going to have to do is describe what the operation and maintenance activities will be. It could be for something like a bridge, they may be fairly negligible because once you have built it, hopefully, knock on wood, nothing much goes wrong with it, and it's good for 20 to 30 years. On the other hand, if you have something like individual home slow sand filters, there's going to be a lot of operation and maintenance that each home member is going to have to know how to do, and so you're going to have to describe those activities to the TAC in detail. Then you're going to have to let us know what resources are required to carry out the operation and maintenance. And a lot of times, really, the most important one ends up being the first one there, is the financial resources. It could be that the community, they have folks that are great at maintaining water system because, maybe they work in that in a neighboring town. They have the manpower to do it. They can buy the materials. It comes down to the financial. Can they afford to do this, the operation and maintenance, in the long term? And, things like a bridge where there is very little operation and maintenance probably is not going to be an issue. For something where perhaps you have a water system that's dependent on a pump, well, the community is going to have to replace that pump at some point, probably within 5 years, and they better have the financial resources to do it. You can't say, well, we've brought 2 pumps down so that if one goes out, the community can use the other, because that still doesn't solve the problem. You have to solve the long-term problem of they have to be able to maintain this on their own without your help or outside expertise, outside financial help. And so if you get to this point in your 525 document and you figure out, oh my gosh, this financial aspect is just not working out, it may be that you have to redo a lot of your design until the financial aspect does work out. And then in the operation maintenance section, describe how these are going to be supplied by the community, the financial resources, the technical expertise, the administrative resources, the materials, et cetera. Just show us that you have thought this all through and have made a rational engineering analysis and judgment that indeed the community will be able to operate and maintain it in the long term. And then let us know what the administrative structure of the operation and maintenance is. You know, a lot of times what can happen is that there's no one person or one committee that's ultimately in charge, and so it ends up nobody's in charge. Make sure that you know and you've worked out with the community, this is who's in charge. Next we come down to ownership. And I kind of threw this one in here because I always thought this was self-explanatory, but now I've come into a few chapters that they've implemented stuff, and one chapter in particularly, they implemented a great well. They did a fabulous job implementing it, but now it's on land they're not exactly sure who owns that land, and so they're not sure who owns the well. Clearly, we want to get all this worked out at the very beginning of the project. So perhaps, you know, next time I do this webinar, I'll move ownership up to the front so that you think of that first before going through all the other, the design. But that comes to an end now of what we expect in the report itself. Let me just give you a couple quick tips for getting quick approval for your document. So number one, be complete. And I said this before, but let me stress it again. You know, you have to give the TAC enough information to make their decision. Remember, they're trying to make that decision of whether you've done enough engineering work to protect the health, safety, and welfare of the public. If you don't give them enough information to make that decision, they can't approve your project. So make sure you give them the information they need to make that decision. Secondly, you know, one thing that a lot of good chapters do is they have their document reviewed by an independent either person or sometimes it's a whole review board prior to submission to us. So they have the whole thing reviewed and vetted by an independent party before we even see it. I mean, the likelihood that you're going to have success on that is a lot higher than if you just send it right into us. Again, and I've said this before, I'll say it again because it seems like once every month or two somebody gets caught here and they don't submit their document on time, to which I can only say, submit your document on time. Make sure to include a site-specific health and safety plan with your 525 pre-implementation document submittal. And then lastly, start your preparations early. Going through a design and putting all the calculations together, putting all the drawings together, then packaging it up into this nice document, it just takes a lot of time, and you're not going to slap it together at the last minute. You know, so what I always say is start at the end date. So you know you're going to travel in January, work back to October 17th or whatever it is being the submittal deadline, then just figure, okay, well, we need, 2 weeks for review before we get that. So you're at October 3rd. We need review by an independent party 2 weeks before that. So you're, middle of September. It takes, 2 months to design or whatever. So if you haven't started your design by the end of June, basically you're already too late. So go through that kind of an exercise. It'll probably scare you, but you will have a better chance of getting your document in on time. And so that's all I have for our presentation today. And if you have questions, please contact your project manager. And I thank you for viewing the webinar today. And I will go ahead and send it back to our moderator. Thank you very much.
Thank you very much, Peter, and thanks to our participants for your attention. I want to take this opportunity to once again remind our participants that you must complete and submit your attendance on the following webpage to receive credit for attending this program. This concludes today's program, How to Complete the 525 Pre-Implementation Report, brought to you by Engineers Without Borders USA and Contract Solutions Group. Please check our online catalog often for the latest instructional programming from EWB-USA and Contract Solutions Group. This program is copyright 2010 by EWB-USA, all rights reserved. Thank you for joining us for this program, and enjoy the rest of your day.